Okay, hi. So today I'll introduce the next topic of our lecture. It is a vector, right? So the vector. So I just named it actually the vectors for down, right? So it is the vectors for down, right? Okay. Okay. So all of you know from your class 9, 10 sense that the physical quantities are broadly classified into two sectors, right? The physical quantities are broadly classified into two sectors. So one of these actually a scalar and another one it's a vector, right? All of you know this scalar and vector, and probably if I asked you, please give me some example of scalar, so obviously you will give some mass, the scalar quantity, length is a scalar quantity, speed, obviously scalar quantity, and just so on, right? And examples of some vector quantities are it's a force, right? Force, velocities, displacement, and so on, right? Okay. And if I ask you that the difference between the scalars and vectors, so hopefully all of you to tell me that the scalar quantity means a quantity which has just magnitude, I mean values. Scalar means which is just the values, I mean magnitude, and the vector means it has the magnitude, I mean the values, and as well as the direction, right? So the scalar means scalar quantity means it has the only magnitude, and the vector quantity means the magnitude and as well the direction. Okay. Okay, so it is your class 9, 10 sense of scalar and vector quantities. But it is not the sufficient definition of scalar and vector, right? So, what is the actual definition? Just as an example, consider if you bought some fruits, like just brought some fruits, let's as an example 2 kg apple, 3 kg, 2 kg apple, 3 kg somehow mango, the apples and the mangoes, and 4 kg oranges, right? Okay, so we just bought some fruits like 2 kg apples, 3 kg mangoes, and 4 kg oranges. And if I asked you what amount of fruit if you bought actually, so it is very simple for you. Probably you will answer just 2 plus 3 plus 4, I mean 9 kg of fruits, right? 9 kg of fruits. Okay, it is very simple because you just add this thing 2 plus 3 plus 4, then 9 kg, right? 9 kg of fruits just bought. Okay, so and Just consider another example. Right. If I tell you, please go from A to B towards east, from A to B towards east for 3 kilometers, right? Please go 3 kilometers from A to B, right? And then please turn left and please go 4 kilometers towards north, because all of you know the east is the north, the west is the south, right? Just 3 kilometers towards east and 4 kilometers towards north, right? So it is somehow 4 kilometers towards north. Okay, so the initial position of you is the A, is named it I, initial position, and the final position of you is named it F, right? Okay, so now if I asked you what is the length in between initial to final position, that means is the length, right? Okay, I just named it C here, the last positions of U. So what is the length in between A, C? Okay, so I think it will not go through 3 plus 4 equals to 7 kilometers, right? So you just not go 3 plus 7, just do not, because okay, so just 3 plus 4 equals to 7 kilometers, because it is not true the length in between initial to final position, right? So you will not go in that scenario, right? But rather you will find the length on the way. It is actually a right angle triangle here, and the AC actually hypotenuse, right? And obviously you will apply the Pythagoras theorem here, right? The length of AC is actually root over 3 square plus 4 square, because height square plus base square, that means root over 25, that means 5, right? It's a 5 kilometer. Okay, so it is actually the length of AC, 5 kilometers, right? Just see what you did, right? You will not go just 3 plus 4 equals to 7. Just can't do this thing, right? You will apply somehow the Pythagoras theorem here. And root over 3 squared plus 4 squared here, it's a root over 25, that means 5 kilometers. Okay, so it's an one example, it's a number 2 example, right? Okay, just look at this stuff here, 1 and 2. Just for 1, the case, what you did actually, it is actually these are 2 kg apples, 3 kg mangoes, and 4 kg oranges, right? It's a kg here, right? It's a kg, and the kg is actually the unit of mass, right? All of you know that kg is actually the unit of mass, right? The unit of mass. And the mass is actually a scalar quantities, right? So just addition of scalar quantities, I mean just to total amount of fruits here, 2 plus 3 plus 4 will answer 9 kg fruits. That means the addition of some scalar quantities, the kg here, kg is the unit of mass and mass is the scalar quantities. The addition of scalar quantities is actually follows your class 3-4 algebras, right? This is 3-4 algebra, right? Just 2 plus 3 plus 4, that means 9 kg. All of you know this thing, your class 3-4 algebras. It is actually called the classical algebra, right? So actually the scalar quantity follows our normal classical algebra, I mean class 3-4 algebraic sense, right? But here is the problem. Just it is not actually the length in between A and C is not a 7 kilometer. It's not 3 plus 4, I mean 7 kilometer, right? Because just look at this stuff very deeply. What is this actually? I introduce some directions here, right? Some directions here. Actually, I told you just go from A to B towards east. I mean just I introduced some directions here. Directions, right? And then turn left and please go towards north. It is also a directions here. And all of you know direction means a vector, right? Vector means magnitude in the values. 3 kilometer actually the values, right? The values actually 3 kilometer, and these are directions here. So towards east is actually directions, right? And towards north obviously directions, right? So it is actually a vector quantities. 3 kilometers towards east and 4 kilometers towards north is actually a vector quantities, and obviously the addition of vector quantities like A to B and B to C, so it is not actually 7 kilometer, right? It is a 5 kilometer. Okay. So it is actually crucial findings here that the addition of vector quantities doesn't follow our normal class 3-4 algebra, right? It doesn't follow like 3 plus 4 equals to 7, 3 plus 4 equals to 7, but it is somehow a different, it follows it somehow a different type of algebra, right? It is 5 kilometers, right? Because it is a vector quantities here. The A to B, B to C is a vector quantities. So actually, the difference from scalar to vector, actually, the scalar quantities follows our normal algebra, our normal classical algebra. The vector quantities doesn't follow our classical algebra, I mean our class 3-4 algebra, right? So actually we will not get 3 plus 4 equals to 7, that means it's not a length actually. AC means it's not actually 7 kilometer, it is just 5 kilometer. So because it involves directions here, right? Because it is the vector quantities. The vector quantities doesn't follow our classical algebra, I mean class 3-4 algebra. Okay. So to add or to subtract, to multiply of 2 vector or 3 vector quantities, so we have to need some another kind of algebra, right? It is not our classical algebra. So you have to need another kind of algebra, right? So now here comes in that scenario the vector algebra, right? It is a new kind of algebra for the addition of subtraction and multiplication of the vector quantities. It is a new kind of algebra. It's called the vector algebra, right? Or you can just a harder name. You can name it quantum algebra. Okay, just ignore the name quantum. just it's a vector algebra, right? Okay, so actually the difference in between the complete definition of scalar and vector is not only the scalar means it has only the magnitude, and the vector means the magnitude as well as direction, but the complete definition is that the scalar quantity means which follows the normal algebra for addition, subtraction or multiplications, but the vector quantity doesn't follow our normal classical algebra as in class 3-4 algebra. So it follows some new kind of algebra, that means a vector algebra. Okay. 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 So just let me introduce the vector algebra here, because our topic is actually the vector for dumb, I mean the vectors. Okay, algebra of vectors, something like that. So just let me introduce the vector algebra here. Okay. So before we proceed the vector algebra, we have to know some basic information about vector, right? Just some basic information, right? Okay. So what is the information actually? First of all, there are two representations to represent a vector quantity, right? There are two representations. One is our geometrical representation, and another one is our algebraic representation, right? Two representation here to represent the algebra of vector quantities. So one is the geometrical representation and another one is the algebraic representation, right? But I will follow firstly actually geometrical representation, because it is a very smoothly adapt for you. Actually, it is very smooth for adapt, right? So I'll just introduce geometrical representation. Okay. So in geometrical representation, I will just draw a straight line here. It is a straight line and an arrow, right? So it is the geometrical representation means a straight line and an arrow plus arrow, right? And nothing else, just a straight line and an arrow, right? Okay. The straight line and an arrow. Okay. Okay. So the length of this straight line is actually means the length of this straight line, that means here is the length of this straight line indicates the magnitude of vector, I mean the values of vector. The length of this straight line, length of straight line means it indicates the magnitude of vector or the values of vector, okay, and the arrow indicates the direction of vector, right? The length of the straight line here actually, the length of straight line means the magnitude or the values of vector, and an arrow indicates the direction of vector, right? Okay. Now it is a complete figure, right? Complete geometrical representation, because in your from your class 9-10 sense, all of you know the vector means the magnitude and as well as the directions. The magnitude means the length of the straight line and the arrow indicates the direction. So if I just call, it is, so all of you know the force the vector quantities. So if I take, it is a 2 unit here, it is a 2 unit. The length of this straight line is a 2 unit and is directed towards east, right? It's the east direction, it's a north, it's a west, it's a south. So that's 2 units of this length and is directed towards east. Okay. So if it is in force, so just call it 2 Newton force towards east, right? Towards east. This is very simple. 2 Newton force towards east. Oh, the length of the straight line signifies magnitude or vector, and the arrow indicates the direction, right? Direction of vector. So these are complete significance or complete figure here, right? So if it is a 2 unit, I mean 2 Newton force here towards east, if I double it, I mean if I just twice that straight line, that means just twice of it. Okay, so I raise some here, just twice of it, that means just double of it here and here. So it is this double, I mean the length of this straight line goes double from here. So it is, if it is a 2 Newton, so obviously double of 2 means 4 Newton, right? So it is a 4 Newton force towards east. Okay, it is very simple, right? Okay. Now obviously it's not just the integer multiple, it is maybe a fractional. So if I introduce here the 3 Newton force towards east, I mean if it is a 1.5 times of 2 Newton force here, so it is a 2 Newton force and it is a 1 suppose. So it is a 3.5 Newton force towards east, right? Because just 3.5 means just a 1.5 times of this straight line, right? So it is a 3.5 Newton force towards east, right? Okay, it is very simple. It is a geometrical representation of vector. Okay, so now if I introduce 2 Newton force towards north, 2 Newton force towards north, that means the length will be the same because it is 2 Newton, but the direction of this thing is towards north, right? The length is the same, and probably the same length, and it is directed towards north, right? So it is, so it is a 2 Newton, the length, right? The length is same here. Okay, so there is 2 Newton force towards north, right? Okay, and then 1 Newton force towards north means just half of it. So it is a 1 Newton force towards north. That means just a very simple, just half of this straight line, and the values of this straight line goes to half. That means 1 Newton force towards north, right? Is a 1 Newton force towards north. Okay, so it is our number 1 information of to represent the vector quantities with a straight line and an arrow. It is a 2 Newton force, just double of it. Its length of this straight line goes doubled. The numerical values goes doubled. 4 Newton force towards east here because it's the east direction. This is a 3.5 Newton force towards east. That means it's the 1.5 times here. The length of this straight line is actually 1.5 times from this thing. It's it's 3. 1.5 times of it means 3. Okay, I'm sorry. It's a 3 Newton, right? It's a 3 Newton force towards east. And then the 2 Newton force towards north, that means the length of this straight line will be same, but direction of this thing towards north. And if I will introduce the 1 Newton force towards north, that means the half times of this straight line, that means 1 Newton towards north, just half Newton. Okay. So it is our very simple thing. Okay. Okay. So just name somehow here. Just name it. Just name it. It is a A, right? If it is a vector quantity, just named it A. It's a 2 Newton, right? So just named it, right? Just A. But the problem is that it's a special kind of thing, the vector. So just put it an arrow on the top of A, right? So it is a vector. It represents a vector. So if it is A, just put an arrow. Just name it A and put an arrow on the top of A, right? So it is a vector, completes the vector. A and is a directions. It is a double. This straight line is double of it towards north. So it is the 2A. You can suggest it is a 2A. Just double of A, 2A. And it is a 3 Newton force towards east. I mean, the magnitude will be 1.5 times of here. So 1.5 times of A, right? So just 1.5 of A. Okay, so and then it is there. Actually, it's not the same thing because the magnitude is the same, right? 2 units here, but the directions towards north actually. So it is another vector, right? Because the vector means length, I mean the magnitude as well as the directions. So actually the directions here is another kind of thing. Is it towards north and it's towards east. So I will call it another quantity of vector, that is vector B, right? Because it's not the same thing, not the same A, because A means directions towards east and the length, I mean the magnitude is 2 Newton. Here actually the magnitude is same, but its direction towards north. Just another kind of vector here, right? So B, because vector means the directions as well as magnitude. Okay. So if it is B, it is obviously half of that length. That means half of B. Right? Okay. So it is very simple case. It is a number 1 information of vectors, right? Okay. So it is all that thing. Number 1 information about vector. Number 2 information about vector is actually the equal vectors, right? Equal vectors. Equal vectors. Right. So equal vectors means the 2 or 3 vectors are equal if the magnitude as well as the directions of these 2 or 3 vectors are same, right? The magnitude will be same, the magnitude or the values will be same, as well as the directions will be same, right? Directions will be same. That means, for an example, here it is some kind of vector A. The magnitude same and directions also same towards the same direction. It will be A, same thing, because the equal vectors. If it is A, then it is A, because the length of the magnitude of these two are same and directions also same. Obviously it is an A, because obviously the 3 stuff here, the magnitude and the directions are same, right? Okay, but these vectors and these vectors are not the same thing, right? if you call it A, then you can't call it A because these two vectors have the same directions, but the length is not the same, right? I mean the magnitude is not the same. It is something different. If it is somehow 2 unit, it is somehow half, I mean 1 unit, right? Half of these two. So you can't call these two vectors are same. So it is A, then obviously it will go another name with B because these two vectors are not same. Equal vectors means the vectors having the magnitude and as well as the directions are same, right? So this set of vectors are equal vectors, but this set of vectors are not equal vectors, right? Okay. Just take another example here. Okay, so just erase it. So just take another example here. Here, oh sorry, it's not parallel, right? So here, okay, the three stuff here, and then it is three stuff here, and then it is okay. So actually it's a number 1 set, it's a number 2 set, it's a number 3 set. Now if I ask you which set represents the equal vector set, right? So obviously your answer will be from our previous just definitions or the previous workout. You will go, your answer will be actually the number 2, right? Because of the number 1, these vectors have the same length, right? But these two are same directions, but the number 3 is actually the opposite directions. So this set of vectors is never suggest the equal vectors, right? The number 2 here is all the 3 vectors having the same length and the same directions, right? The number 3 here, all the vectors has the same directions, but these vectors, the magnitude of these vectors is somehow smaller from these twos, right? So actually this set of vectors actually are equal vectors. If I call this is A, then obviously it is A and obviously it is A, but you can't represent it is A, but it is not A, okay, because the direction of this thing is not the same as these twos, right? And if I represent here A, obviously it is A because the length of these twos is the same and direction is obviously same, but it is not actually A because maybe the direction is same, but the magnitude of the values are not same. It is somehow smaller from these twos, right? Okay, so it is actually our similar set, I mean equal vectors set. If it is A, then obviously it is A and obviously it is A, right? Because the definition of equal vectors means the magnitude will be same, the directions will be same, right? Okay. Now the third information of the vectors is actually opposite vectors, right? Number 3, opposite vector. Opposite vector. So what is opposite vector? If the two vectors has the same length, two vectors, the definitions of opposite vector, the two vectors has the same length, but the directions is actually opposite to each other. But direction is opposite to each other, right? The direction will be opposite. That means if it is A, the same length, two vectors have the same length, that means this is the same length, right? But direction, if it directs towards east, then if the second vector is opposite vector, then obviously it will direct towards west. I mean this thing. Okay, it is the opposite vector, right? And obviously, from your common sense, if it is A, then obviously it is a minus A, right? Just opposite, no? Just opposite. I mean, this, if it is a number line, 0 here, 2 here, the minus 2 here, then the opposite of 2 means the minus 2. Similarly, the opposite of A means the minus A, right? This is a very precise, and a very simple thing, right? Okay. The two vectors has the same length, but the direction of these two vectors are opposite to each other. Then the two vectors are called opposite vectors, right? And if these vectors are named A, then the opposite of this A are named minus, right? Just opposite thing. Okay. So it's a minus. Just directions opposite. The length will be same, right? The length will be same, but opposite in directions, right? So this is a number 3 information, and the last information here I'll introduce to you. It is very interesting. Number 4 information. It is actually a parallel transformation theorem. Parallel transformation, or the parallel shifting theorem. You can call it the parallel transformation theorem or the parallel shifting theorem, right? That means if I draw a vector here, just for an example, just take my marker pen is a vector, right? And the open cap here, it is a directions, and the length of my marker pen is here. Okay. So if I shift my marker pen in the board here to here to here to here, just parallelly shift. Just parallelly shift here. It was there and I shift here. Just parallel shift. Oh, sorry. I just parallelly shift here. It is there and I shift here. Just parallel shift. Okay, just parallel. That means the length of my pen will remain fixed here, right? The length of my pen, that means the magnitude of vector remains same, and the directions will remain same because I just parallel shift here, right? Just parallel shift here. So from here to there, here to there, right? Just I shift this pen parallel to itself, here to there, to there, to there. Okay? Here to there, to there, to there, to there. Okay. Just look at this stuff here. Actually, oh sorry, it's not parallel, right? It is not parallel. It is a parallel thing somehow. Okay, so actually the directions will remain fixed because I shift my pen actually parallel to itself. The directions remain fixed, right? Direction remains fixed as well as the magnitude of my pen remains fixed, because if the pen goes from here to there, the magnitude of this pen, I mean the length of this pen will remain fixed, right? The magnitude, I mean the length of this pen would not be changed, right? So the magnitude of this vector could not be changed, and obviously I will shift it parallelly, then directions will be same, right? Okay. That means if it is a vector A, then all of this thing, the vector A actually, right? It is a vector A, it is a vector, it is a vector A. Because from our previous definition, I mean the information number 2 probably, equal vector means the vectors has the same magnitude as well as same direction. Just look at this stuff here. Same magnitude because it's my pen here. The length of my pen remains fixed. That means the same magnitude, and I shifted my pen just parallel to itself. That means directions will remain same. All the vectors directed towards somehow northeast, right? Probably northeast. All the vectors directed towards northeast, and all vectors, the magnitude of all vectors remains same. So actually the parallel transformation theorem or the parallel shifting theorem of vector tells that if you shift the vectors parallel to itself without changing the directions, all the vectors remain fixed, right? If you shift the vectors parallel to itself without changing directions, then all the vectors will remain same actually, right? If it is A, then obviously it is A, it is A, it is A, it is A. Because I just shift my marker pen here, the length of my marker pen should not be changed, right? The length of this vector unchanged, and I shift parallel to itself, that means the direction obviously remains fixed. Okay, so it is our number 4 information of the vectors is the parallel transformation theorem, a parallel shifting theorem, right? Okay, so it is all of the informations of vectors, right? Okay, so now I cooked all the recipes here to introduce our vector algebra. Okay, now, so in the next class I will introduce the vector algebra. I mean the addition of vectors, subtraction of vectors, the multiplication of vectors, all the vectors algebra. So, okay. This is the end of our part 1 classes of vectors. I mean the vectors for now. Okay.